Hello student, today I will discuss the galvanometer. We know that galvanometer is used to check the current in the electric circuit. If we have connected galvanometer in circuit and galvanometer is showing null deflection, we conclude that there is no any current in between the two terminals. So both the terminals are at equipotential. That is one. Secondly, the circuit may not be completed. So in this way, current can be checked in the electric circuit by using galvanometer. At first, we will study construction of the galvanometer. Galvanometer consists rectangular coil. See here, in this way. Upper portion, vertical sections. So this is rectangular coil of thin insulated copper wire. Let having n turns. N be the turns. A be the area of coil. And this rectangular coil is around the iron core cylinder. And it is suspended or it is pivoted. Two types. Coil may be suspended or coil may be pivoted. In between two pole pieces, concave shaped cylindrical horseshoe magnet in this way. So north pole, south pole, and coil is pivoted by means of the two springs. I have shown the above spring. There is another spring which is below the coil, and there is a pointer attached, and there is an angular scale, and that is our galvanometer. So what galvanometer consists? Basically a rectangular coil having n turn, A area. It is around the iron core. It is pivoted in between two pole pieces of horseshoe magnet, concave shaped horseshoe magnet. And there is a pointer. Current will flow in the coil. So I have not shown the two terminals of coil. But current will enter in the galvanometer. That means current is entering in the coil. And as current is flowing in a coil in this way or in this way, okay, as current is flowing in the coil, there will be magnetic forces on the two sides. And these two equal and opposite forces will form couple. And that couple produces torque. And torque is given by NIBA. Here, N is number of turns, A is area of coil, I is current flowing, and B is the magnetic induction produced by these concave pole pieces. Okay? So that is torque. And due to this deflecting torque, the coil in this way, coil will deflect. And so pointer, which is initially was at 0, will get deflected in this way. Okay? So deflection can be measured on angular scale. So that is deflecting torque. And if it is equal to restoring torque, K theta, where theta is deflection, then we will get the equation for current, which is simply in this way. Here all these are constant, and so current produced in a coil is directly proportional to deflection. That means if galvanometer is connected in the circuit and it is showing very small deflection, what is our conclusion? Current is small. If it is showing large deflection, out of scale deflection, what is our conclusion? Large current is flowing in the galvanometer. Okay? So in this way, that is the basic principle of galvanometer. Current flowing in a coil, current flowing in a galvanometer is directly proportional to deflection produced. No doubt. This is pivoted coil type moving coil galvanometer. There is another one which is called as suspended coil top moving coil galvanometer. This is pivoted. Coil is pivoted here by means of two springs. One is below and one is above. And the pointer is attached. Do you get this point? So very easy. So that is the construction, and this is principle of working of moving coil galvanometer. As current is flowing in a coil, there is a deflecting torque. That's why coil deflects. And deflection is equal to restoring torque, and so current is directly proportional to deflection. Do you get this point? I proportional to theta.